Hi friends, my name is Vivekanandan. I am student of Sri Venkateswara College of Engineering, Bangalore. In this video, I am going to discuss about Introduction to Data Science. Let's see contents. What is data science? The data science life cycle, data collection and pre-processing, exploratory data analysis, future engineering and model selection and training, model evaluation and validation, deployment and monitoring, ethical consideration in data science. Now let's see what is data science. Data science is an interdisciplinary field that combines statistics, mathematics, computer science, and domain-specific knowledge to extract insights and knowledge from data. It is involves the collection, processing, analysis, and interpretation of large and complex data sets to solve real-world problems. Data science uses a variety of techniques such as machine learning, data mining, and predictive modeling to uncover hidden parts, trends, and relationships within data. The insights gained from data analysis can then be used to drive decision making and inform business strategies. Now let's see data science life cycle. Define the problem, clearly identify the business objective and question to be answered. Collect the data. Gather relevant data from various sources. Prepare the data. Clean, transform, and format the data for analysis. Explore the data. Analyze the data to uncover patterns and insights. Build the model. Select and train the appropriate machine learning model. The data science lifecycle is a structured process that guides the development of data-driven solution. It involves defining the problems and collecting, preparing the data, exploring the data, building the data, and evaluating and deploying the solution. Now let's see data collection and pre-processing. Data source. Data can be collected from variety of sources, including web scraping, API, database, and surveys. It importance to understand the strengths and limitation of each data source. Data cleaning. Raw data often contain error, missing values, inconsistency. Cleaning and pre-processing the data is crucial to ensure that high quality input for analysis and modeling. Future engineering. Creating a new features from a new raw data can be improve the performance of machine learning models. This may involve transforming variables, combining feature and extracting insights from text or images. Handling outliers. Identify address and outliers in the data is an important step to ensure that reliability of an analysis and model result. Technical like winsuration and robust regression can be used. Now let's see exploratory data analysis. Understand the data. Exploratory data analysis can call as a also EDA is the crucial step in the data science process. It is involves closely examining data set to understand its structure and identify the pattern and uncover insights. Identify relationships. EDA helps analysts identify relationships in between variables and detect outliers and understand the distribution of data. This lays the foundation for a more advanced analysis and modeling. Visualize the data. Powerful data visualizations such as the scatter plots and histograms and heat maps are essential tools in EDA. They enable analysts to quickly spot trends and anomalies Other key characteristics of the data: informed decision. The insights gained from EDA inform the selection of appropriate modeling techniques and guide this future engineering process. EDA is a iterative and exploratory journey that lays the groundwork for a successful data science project. Now let's see future engineering. Data transformation. Transform raw data into a format suitable for modeling by cleaning, normalize, and encoding features. Future selection. Identify the most relevant and informative feature for including in your models and eliminating redundant or irrelevant data. Future extraction. Create a new feature from existing data that better capture the underlying patterns and relationships. Now let's see model selection and training. Model selection. Choose the appropriate machine learning model based on the problem, data, and desired outcomes. Common models include regression, classification, clustering, and deep learning. Hyperparameter tuning. Optimize the model hyperparameters like our learning rate and regulations and model complexity to improve performance on the validation set. Training strategy. Employ best practice like a cross validation, re-regulation, and early stopping to train model. Generalize the well and avoid fitting. Interpretable priority model interpretability to understand how the model arrives at its prediction, which is crucial for a real world applications. Now let's see model evaluation and validation. Accessing model performance evaluate the accuracy and precision. Recall F1 score. Your machine learning model ensure that meet the desired performance target. Cross validation technique. Leverage to technique like a K-fold cross validation. Rigorously test your models on seen data and validate their generalization capabilities. Ongoing monitoring, continuously monitoring your deployed models for a draft and other performance issues, and be prepared to retain or fine tune them as a need. Deployment and monitoring. Deployment, the final step in the data and science life cycle, is deploying the trained model into production to make a real world predictions and insights. This requires integrating the model with existing systems and infrastructure. Monitoring, continuous monitoring of the deployed models in a crucial to ensure its ongoing performance. Identify any draft and degradation in accuracy over time. This enables timely updates and adjustment. Performance evaluation. Regular evaluation of model performance and metrics such as accuracy, precision, and recall helps validation and effectiveness in the production environment and drive further improvements. Now let's see ethical concentration in data science. As the data science becoming more influence, it is a crucial to consider the ethical implications of how data is collected and analyzed and used. Key concern including a privacy and bias, transparency, and potential for a misuse or unintended consequence. Data scientists must be uphold high ethical standard, priorities the well-being of individuals and society, and strive use data in a ways that are fair, responsible, and beneficial. Thank you.